Hello, everybody, and welcome to another session where we're continuing our discussion on units of measurement. Units of measurement. All right, let me just check my volume here. Okay, looks good. All righty. So we didn't finished. We did not finish last time. I finished in a way that was sort of strategic so that it gives you some time to go and figure out where you're at. What do you need to do, or are you okay with what we've done and how we did it? So we ended with exercise 11.3, but only did number one. Now, whether you did the others or not, that's up to you. We will do 2, 3, and 4 next. Now, I accidentally deleted some of my conversion table. I still have this one after I realized, oh, don't delete the other one. I saved this one. So let's just write down uh, what a table, the other table could look like. We have 1 yard will correspond to 3 feet. We have, in no particular order, it really doesn't matter, right? 12 inches will correspond to 1 foot. We have a mile. That'll correspond to 1760. That's an ugly 6. 1,760, whoops, yards. And maybe we want our conversions over here, linking the two systems. Again, this isn't 100% accurate, but it's sort of a day-to-day practical conversion. That 1 mile is roughly 1.6 kilometers. Ask Google and you'll see it isn't exactly. In truth, it's 1.60934. And now I know there are some of you that say, yeah, if I do a mile to kilometer conversion in my head, of course I can easily multiply in my head by 1.60934. Of course, why can't you? Well, you know, not everyone is as skilled, and it gets the job done to work with 1.6 instead for convenience and still be pretty close. Am I going to do a physics calculation for a company where every decimal matters? No, I won't use 1.6 then. But for day-to-day conversion, that gets the job done. So why not? Then also I have 1 inch corresponding to 2.5 centimeters. Is it exactly 2.5? No, it's more like 2.54. Do I really care on a personal, practical, day-to-day, casual level? No, I don't. It does not keep me up at night. I'm good. So, depending on what the table gives you, you have to work with that. You're welcome to ask Google, but it's not going to get you any marks. And if you ask Google, Google will probably use the precise conversions, right? And your answer is not the answer we should be getting. We should be using the table information as it is given. So be very careful. This is not the place to use Google to verify your answer. It won't match to every decimal. Why did I make a new page? Oh, just a habit. I could just go underneath here for number 2. So what is number 2? I don't know. 2 decameters into yards. Now, I use decameters all the time. Of course I do. But it's the less common one of the lot for sure. 2 decameters. Now, decameter sits sort of in between the kilometer and the meter, right? The hectometer and the decameter. Just to be thorough, they wanted every power of 10 to have its own name. Practically speaking, we're okay with meters and kilometers, but it's right there. So first I need to Make a chain and plan. I wanted yards, right? Wow, I have a terrible memory today, and tomorrow, and yesterday. I want to go to yards, so I need a plan before I start calculating. I'm going to start in decameters. Then, given the information in my table, I have to get to yards. I can go down to meters for sure. I just want to make it simple. You could go, well, I can't because I don't have a decameter to kilometer or decameter to centimeter direct conversion. You have to show every step using the table. Now, again, I'll mix it up. I won't do two every time. You can go up to kilometers. You can go down to inches. Who knows? I'll accept both because you have that option if both of them are given. Let's go up to kilometers this time. Why not? So I can maybe go up to kilometers, and I have to go via meters because of what the table gives me. That's the whole point, right? We're testing if you can use this table as it is. Kilometers, then to miles, maybe. This is just one option. It's not the only option. And I don't really care how long this plan is. Don't really care. Miles, because I want to get to yards. I can go to yards right away then. Yards, and that is my end goal. Okay, it's a plan. It's a good plan. So now I want to have my decameter to meter conversion. Decameters will be at the top, meters, sorry, bottom, meters at the top. Uh, 1 decameter, 10 meters. Right, that's what it says here. Just whatever the table says. And now I'm in meters because the decameter unit cancels. Next, I'm going to go and take that to kilometers. So meters at the bottom, kilometers at the top. 1 kilometer is 1,000 meters. I don't care about the calculation. I'm just tracking my units, and now I'm in kilometers. That's the only thing I am concerned with here. 1 kilometer mile, according to the table that they give me, kilometers will be at the bottom, miles at the top. 1 mile, 1.6 kilometers. Now I'm in miles, then I can go to yards, miles at the bottom, yards at the top. Erase my line, that bracket, because it bothers me. What was it? 1 mile, 1760 yards. That's what the table says. That's what I use. And then I'm in yards because kilometers canceled there, miles canceled there. My answer is going to be in number of yards. Now I can go and say, okay, let's just calculate it. I've kept track of my units, correct unit. Let's see what the number part is. So it is 2 times 10 times 1760 divided by 1,000 divided by 1.6, and we get, oh, that is a noise, 22. Again, take the inches root, inches to centimeters. You will be a little different than that answer. I will always accept both because our table isn't presenting the most precise conversions. Different paths will be slightly different, and that's okay. That's okay. Based on our needs and our goals. Hopefully that's what you got if you took this route or close to it. I'm just curious. I'm just curious here. Let me see what Google says. What was this? 2 decameters. Decameters into yards. Let's see what it says. Decameters to yards. 21.87 because it's using behind the scenes the correct, precise numbers, right? So we're pretty close. So that's really all I can use Google for. For this test question, is it close? That's probably okay. The test here is to use the table and show your work. Okay, enough rambling. What's the next question? 235 kilometers into miles. Oh, I should have started with those. Those are much easier. Wow, this is so backwards. 235 kilometers to miles. Wow, we should have done them in the other direction. 235 kilometers. I have one step conversion for that. 1 mile, 1.6 1.6 kilometers, and I'm in miles. Wow. Okay. Hindsight. Sometimes it's gonna be that simple. Sometimes it's a longer chain. Just do what it needs from you. So we have 235, in this case divided by 1.6. And the benefit of this, as well as the ratio equation in general, is that you never have to think, do I divide by 1.6? Do I multiply? When do I do what? How do I decide? How do I know? Because you get people that say, like, oh, I need to divide by 1.6. That's all you do. Just divide by 1.6. Okay, and then you ask them, okay, why? I don't see it. Why do you divide? Oh, I just know. I just see these things. Right? That's not what a teacher should be like, and that's my ultimate goal. Perhaps these things are super obvious to me, but if depending on my audience, it's not going to be, and I need to be ready for that scenario because that's ultimately why I have this knowledge to pass it on. Last one is also extremely straightforward in terms of the chain that I'm going to make. 5.23 centimeters into inches. Oops, random line. 5.23 centimeters. I have a direct conversion. If they give it to me, why wouldn't they? This is one of the ones that I use a lot. And I see my units check out. My answer will be in inches. I just want to see. And in this case, it tells me you should be dividing. I didn't need to know that beforehand. By keeping track of the units, it tells me what to do. 5.23 divided by 2.5. I'm not looking for shortcuts. I'm not looking for if it looks like this, then you know you divide. If it looks like this, then you multiply. I don't care. Really don't. The setup is going to tell me what to do. There is no trick here. All right. Random cat just jumped on me. That's nice. That's nice. Boundaries. Boundaries, Kitty. Boundaries. Okay. Let's move on to a topic that needs discussion, but is not really brand new. And that is the topic of area uh, units or measurement. Be surprised. We're so used to talking about area and the concept, but how do I introduce that for the very, very first time? If I have an area there, square, rectangle, I don't know, whatever. It's nice to start with something rectangular for sure. I've maybe learned about formulas and all kinds of things, but what does if I say this is 25 square centimeters or whatever, right? What does that really mean? Really mean? Many people have never thought about that. I have to reference this space to a unit area, and I'll decide what the unit is. It depends on the length that is convenient. Could be a centimeter, could be an inch, it could be a kilometer. It depends on the scale that I'm working with, right? This is my reference. This is a 1 unit, 1 area unit, let's say. 1 area unit. And when I try to express the size of this rectangle, I'm going to do that by comparing how many of these little area units can fit in here. 1, 2, 3, 4, and I stack them in and so on. Maybe they fit perfectly, maybe not, but it's the same. And then in the case of a rectangle, sure, it comes down to whatever this length and width is, because I stack them in this way, a certain number of columns, certain number of rows, it's the product of the two, to be able to calculate that. But the shape could be very different and weird. I'm still representing this concept of area by comparing it to how many of the unit sized pieces can fit into this space. So now I'll call this, because of this rectangle, I think we could say, because this rectangle and the rows and column um, result that we get, the number, let's say here, number of little unit blocks that can fit is the length of the rectangle times the width. The length is going to be X number of units, and the height, if you will, or the width is going to be Y number of units. So this will have a certain number of units times a certain number of units there. So whatever the unit is that I'm working in, looking at this and treating these unit names as numbers too, they are multiplied. There are two of them. So we write units squared. So this area unit is the length unit that I'm working with squared, because there are two of them that feature, not just one in the case of a line. If I work with centimeters, I'm looking at my unit as 1 square centimeter. And the area that I represent, the units will be whatever the length unit is, squared. So that means when I'm converting, I just have to remember that the units, there are two of them, and each one needs converting. But then I'm really back in my length unit conversion situation. Scroll up here and we look at exercise 11.4. I'm going to move this over so that I can see it and just copy it down. Exercise 11.4, we'll do it in order this time. I have 50 square meters, or 50 meters squared, depending on how you want to say it, that I need to convert to square kilometers. This is now an area measurement. All I need to realize is this is 50 times the 1 meter by 1 meter unit area. And I'm trying to convert this to a certain number of 1 kilometer times 1 kilometer unit bigger squares. So all I need to do is take one of the length units in meters to kilometers and the other one meters to kilometers again. So all that's really happening here when I'm converting area is I'm doubling up the length unit conversion. So luckily I have a direct step from my table to do that. So I could say, let's do it like this, 1 meter, 1 meter. So I'm expanding what this meter square actually means. And then I'm going to multiply by one reference pair, meters at the bottom, kilometers at the top. 1 kilometer is 1,000 meters, and the 1 meter there unit will cancel with the meter unit at the bottom. But I still have this meter, so I have to do it again. Kilometers at the top, meters at the bottom, 1 to 1,000, and those meters will cancel. And then I have 2 kilometers. And this then tells me I have to take 50 divided by 1,000 divided by 1,000. Let's see that, just to help me keep track of all the zeros. 50 divided by 1,000 divided by 1,000. Nope, I missed my division sign. 5 zeros. Come on, pen, where are you? 0.00005. 1, 2, 3, 4, 5 decimals, yes. Kilometers squared. So it's really nothing new. I just have two of every unit that I need to convert. Now let me just check the 1 0 here cancels with 1 0 0 1 2 3 4 5 zeros. Yes. Second one. Why do I have these wobbliness happening? There we go. So once I realize that, that's really nothing new, and I can just practice my basic unit conversion again. Now I have like 28 minutes to fill, so let me just do them all, I guess. 2 square meters, I could say, is 2 times the 1 meter by 1 meter conversion. I need to go to centimeters, so I'm going to take meters at the bottom, centimeters at the top. 1 meter is 100 centimeters. That takes care of one of the length units, because an area is two-dimensional now, right? There are two length units, length and width, or height, or whatever you want to call it. So I'm just doubling up on everything, and it's really that simple. I don't need new conversion tables or anything. I just still need the length units, because area is built on length. That's not it. That's it. So that then takes care of my second meter unit, and I'm in centimeters squared. There are two of them. So this will be 2 times 100 times 100. Pretty sure we can do that. 4 zeros, so 20,000. Last one. See, the SI units are very convenient because it's all powers of 10. This is millimeters squared, so 5 times the 1 millimeter by 1 millimeter unit that I'll convert to, oh, decimeters. Okay, fine. Let's suppose our table of information that we are restricted to does not have a direct millimeter to decimeter conversion. Even though you know what it is, I have to use my table. So I'll make a little plan here. My plan is going to take millimeters to maybe meters and then to decimeters based on the table. Now I can do it squared here too, right? It doesn't matter. It's the same chain. 1 millimeter needs to go to a meter, and that'll fix that. The other millimeter needs to go to a meter. That will get me into the 2 meter units. Then I need to move that to decimeter. So meter will be at the bottom, decimeter will be at the top, taking care of that one. And again for the other one. And now I'm in square decimeters. Conversion pair for meters and millimeters. 1 meter is 1,000 millimeters. 1 meter is 1,000 millimeters. 1 meter is 10 decimeters. 1 meter is 10 decimeters. It's on the table, right? I just read it off. That then tells me what my calculation should be. There's a lot of zeros to keep track of. Calculator is there for convenience. Let's do it. 5 divided by 1,000 divided by 1,000 times 10 times 10. I know it's not the hardest thing ever. We get 0.0005. So again, if I have a longer chain, everything's just doubled up. That's all. There is really nothing new once I understand what area units are really trying to say, information that they're trying to convey, and how they are built and connected to the length measurement units. But we have to fill our session with something, so let's do the other exercises. When it comes to the English system, it's a little bit more fun because it's not all powers of 10. In exercise 11.5, fun, more difficult, choose whatever word you want. 50 square feet into yards. I have a conversion directly for that. Feet to yards, 3 to 1. So I can go directly and just say, for my clarification, right? This means I have 50 of the 1 foot by 1 foot unit area. And I have to convert both of those side lengths of that square area. Feet to yards, feet to yards. Still pretty laggy. 1 yard, 3 feet, 1 yard, 3 feet. And this then shows me, okay, feet cancels. I'm in 2 yard units, yards squared. So I'm in the right unit that the question wanted. This tells me what the calculation is. 50 divided by 3 divided by 3. I don't need to think about it. I don't need a special area conversion table or anything. 50 divided by 3 divided by 3. And we get, I'll round to 2 decimal places, 5.56. That's it, simple as that. There is really nothing new when it comes to area, and I'm still just practicing the same length unit conversion. Yards to inches. I don't have that directly, do I? I'm going to have to go via feet. So I'll make a plan. Yards to inches. This 2 means 2 of the 1 yard by 1 yard unit square that I have to convert each of the yard units to feet. This another one to feet. This yard unit cancels with that one. This yard unit cancels with that one. Now I'm in square feet that I have to convert each one as well. Feet to inches. Feet to inches. This foot unit cancels with that one. This one with that one. I'm in the right unit. Square inches. What is my conversion for each one? 1 yard, 3 feet, 1 yard, 3 feet, 1 foot, 12 inches, 1 foot, 12 inches. And it tells me then, oh, I should multiply by this. Okay, great. I didn't need to think about it. My setup tells me that for me. Let's do it. 2 times 3 times 3 times 12 times 12. Random line. I only put one equal sign. That's my fault. Sorry. Otherwise, Bot doesn't know what it wants. What I want it to do. 2,592 square inches. Pretty straightforward if I build it on solid understanding. That is always the key. Let's do number 3 in that exercise. Square inches to square miles. 235 square inches. And I want to go to miles, right? So that does not have a direct conversion on my table. Inches to miles. I'll have to go inches to feet, feet to yards, yards to miles. Okay, it's not a big deal. Inches to feet, feet to yards, yards to miles. So this is 235 of the 1 inch by 1 inch square unit. So I need to convert inches to feet. Because they double up, it's going to get a little lengthy, and I'm going to run out of space. That's okay. Then I'm going to, so my inch unit cancel there. I'm in 2 foot units. And then I'm going to go feet to yards, feet to yards, keeping track of the units. Oh, I There, now I'm there. Then I can squeeze it in. I'm gonna convert yards to miles because the question wants miles. Yards to miles is 1 mile 1760. 1 mile 1760. Can this be seen on the screen? For some reason it's very high up, but that's okay. Let's so then yards and yards cancel, yards and yards cancel. I'll do it over here. I'm in my correct area unit, miles times miles. Okay, now the conversion pairs. 1 foot 12 inches, 1 foot 12 inches, 1 yard 3 feet, 1 yard 3 feet, and I've done those already. This then tells me what I need to calculate. I never thought about what I need to calculate until now, and I pretty much just read it off. Let's do it. So I have 235, oh, it's all division, divided by 12, divided by 12, divided by 3, divided by 3. This is not going to be pretty, but I'm doing it anyway. This is extremely small. Let me make more space here. Now, I haven't talked about scientific notation, so I don't expect you to know. Uh, the e to the negative 8 is just exponent negative 8. It's the power of 10. So if you have seen scientific notation before, I can write it like that for you, but we'll say what it means in a second, and so on. Oh man, I have no space for all these digits. Times 10 to the negative 8. All it means is to get the correct number, I need to shift my decimal 8 spots further out. So let's see here. 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, and then 8. We'll double check if I missed a 0 here. And then we can round this a little bit more aggressively. 5, 9. Is that right? It was over here. 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. We won't be too serious about the rounding. And I understand if you don't like exponential notation, it's not that big a deal. To be honest, they do try and introduce that early somewhere. I always found that super silly. That when you get to high school and you need it, it's not a hard thing to introduce there. Whatever, whatever. So don't worry too much about that. Let us see. That was exercise 11.5. Last one. Now I'm going to be smart this time and do it in increasing order of complexity here. Which one is the shortest chain? The last two again. Same numbers. Wow. Who wrote this book? Same numbers, but we're going to do it backwards this time. 11.6 because the last two were the easiest ones. 5.23 square centimeters means 5.23 of the 1 centimeter, by 1 centimeter unit that I need to convert. Now I have a direct conversion to inches. Centimeters the bottom, inches will be the top, centimeters to inches. Cancel the units so that I'm in the right unit. Then worry about the conversion. That is in the table. 1 inch, 2.5 centimeters, 1 inch, 2.5 centimeters. I have to use whatever the table says, regardless of how accurate it is. Let's calculate that. The calculation is shown for me. I just do it. 5.23 divided by 2.5 divided by 2.5. And I don't need to think about it at that stage. My plan, by keeping track of the units, did everything for me. Maybe we want that one to be 4 decimal places. Why not? Same length unit conversion, everything is just doubled up. I'm going to skip number two. Number two. Oh, I'm doing number three. Never mind. I'm going to skip number two anyway. Because decameters. Who uses that? No one. No one. But this one is very relevant. Square kilometers to miles. So this is 235 of the 1 kilometer by 1 kilometer unit that I'll convert each one to miles. Cancel, 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 cancel. So I've checked I am in the right unit. The one that they give me, 1 mile, 1.6 kilometers, 1 mile, 1.6 kilometers. That then shows me my calculation. Let us do it. 235 divided by 1.6 divided by 1.6. And we get 91.7. Ooh, let's round to 4 decimals. Why not? 7969. Mix it up a little bit. Check the instructions. If the question itself doesn't say how many decimals to round, maybe the cover of the test says. Otherwise, definitely ask. Let's do our last one. Whoops, I just clicked on the wrong thing. Okay, I'm just going to skip to number 1. Oopsie. And I'll leave number 2 as an exercise for you. It's all the same, right? We do exactly what we did in the length unit exercise, just double it up. 50 square feet to meters. Let's make a plan. Feet to meters. I'm going to go the short way. Feet to inches, inches to centimeters, centimeters to meters. We did the long way a couple of times. Let's do the short way. Now this means I have 50 of the 1 foot by 1 foot square unit. I will convert each of those foot units to inches. Back of my unit, feet cancel there, so I'm in inches. Well, square inches, I suppose. Then each of those inch units need to be taken to centimeters. Position them appropriately so that they'll cancel. Inches with inches, inches with inches. Now I'm in square centimeters. Running out of space a little bit. I'm going to do it down here. I need to convert the centimeter units to meters. So centimeters go in the bottom, meters at the top, and cancel, 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 cancel to check. And then I'm in square meters for my final answer. Now fill in the conversion pairs, the reference pairs, if you will. 1 foot, 12 inches, 1 foot, 12 inches, 1 inch, 2.5 centimeters according to the table, 2.5 centimeters. 1 meter is 100 centimeters, 1 meter is 100 centimeters. This then tells me exactly what I need to do. My thinking was in the plan and the table, not in the calculation. So let's do it. Times 12 times 12 times 2.5 times 2.5 divided by 100 divided by 100. And we get 4.5 square meters using this table. Whatever table is given, you have to use that and only that. So I am quite confident you can do number 2 on your own. I am not going to do it. I am stopping short on purpose here a little bit to see if there are any questions or anything that you may have. But while we're still recording in our session, are there any questions or comments that you want to add to the discussion? All right. Then we will end our session here officially, but I'll stay for a few minutes to see if anyone has any questions.